morning, dear students. Welcome to science class. I hope you all are doing well. In previous class, we see the right hand thumb rule, according to which when we make a thumbs up in our right hand, so our thumb show the direction of the current and our finger, which are moving inside, shows the direction of the magnetic field. Now today we will see the magnetic field due to current through a circular loop. So if we have a circular loop and current is passing through it, so what will be the direction of the magnetic field, right? So here you can see that if we see in the right of the diagram, so if the direction is in upward, so make your right hand thumbs up. Your thumb is showing the direction of the current. So you will get the direction of the magnetic field, that your finger is in inward direction, so current will be in inward direction. If we see in another phase of the circular loop, if the direction of the current is in downward direction, so make your thumbs down and see the direction of magnetic field will be in inward direction. Your finger is moving in inward. So in this way we can see that the direction of the magnetic field in a circular loop. In fact, when we move away from the circular loop, the magnetic lines will appear like straight parallel lines, because magnetic field is decreasing with distance. Now, magnetic field due to current in a circular solenoid. Solenoid is actually a coil of many circular turns of insulated copper wire wrapped closely in the shape of cylinder, that is called a solenoid. So solenoid is a circular coil of wire in the shape of cylinder, and in this we use copper wire. So when current flows through a solenoid, what will happen? It behaves like a bar magnet, the magnet which have north and south pole. The ends of the solenoid behave like just like magnetic ends, like north and south pole, and the magnetic field produced by a solenoid is similar to the magnetic field produced by a bar magnet. And the strength of the magnetic field depends upon the strength of the current flowing through the solenoid and the turn of the coil, how many coils are turned. Now there is a term, that is electromagnet. So electromagnet is when a strong magnetic field produced inside a solenoid, it can be used to magnetize a piece of magnetic materials, like if we place a soft iron inside it. So after some time, after passing the current, we will observe that it will be magnetized and will become a strong magnet. So the magnet formed with the help of solenoid is called a electromagnet, right? So if electric current is passed through a wire wound around a piece of soft iron, it behaves like a magnet, and such a magnet is called electromagnet. Now force on a conductor carrying current in magnetic field. Now we see the force on a conductor carrying current in a magnetic field. So here we do an activity in which we take a small aluminum rod and we use two conducting wires suspended in horizontal form. A stand, you can see that the aluminum rod is suspended with the help of wire freely, and we place a strong horseshoe magnet This is called, the U-shaped magnet is called horseshoe magnet, in such a way that the rod lies between the two poles. You can see in the picture, we are suspending the horseshoe magnet in such a way that the rod lies between the two poles with the magnetic field directed upwards. So for this, put the north pole of the magnet vertically below and south pole vertically above the aluminum rod. Now we connect the aluminum rod in series with a battery, a key and a rheostat. Now we pass current through aluminum rod from end B to end A. So what we observe? When we pass current, it is observed that the rod is displaced towards the left, and we notice that the rod gets displaced. And if we reverse the direction of the current, then we observe that the rod will move towards right direction. So the displacement of the rod in the activity suggests that the force is exerted on the current carrying aluminum rod when it is placed in a magnetic field, and it is also suggested that the direction of the force is also reversed when the direction of current through the conductor is reversed.